This is part 2 of looking at confidence intervals. Whoops. And this is, you don't have to do a lot of calculation on this one. We went through the whole process on the last one. I would suggest you just take your time and read through this. I'm giving you the confidence interval. In other words, I've already done the calculations for it, and I'm giving the confidence interval. We would typically be talking about lacrosse and baseball right now. And question that often gets discussed in my statistics classes: who actually does their homework, the lacrosse players or the baseball players? So I have this confidence interval given to you. Like I said before, I suggest you pause this, try to figure out an answer to these 3 questions. Interpreting the confidence interval is sort of, if you wrote this out and you finished the calculation here in the last step here, you'd realize that the margin of error over here is actually bigger than the sample statistic, and the difference between those proportions. Now, I intentionally didn't tell you whether this is lacrosse players doing their homework 25% more or baseball players. You can leave that up to your own interpretation. But we do know that if you add these together, there's a 55% more lacrosse players doing their work or baseball players doing their work. But if you subtract them, you get a negative. So it's, again, in one of these situations, if one is positive and one's negative, and the two limits of the interval, the endpoints of the interval, that tells us we can't really draw conclusions about who's doing more homework based on this. So these 2 questions down below, is it plausible that lacrosse players do their homework more? It's plausible, but we're not really decisive on here. It's likely, but not conclusive. So even though I have the word yes here, it's not conclusive. We don't know because it crosses over 0. And kind of the same thing here. Is it plausible that baseball players do their homework more? Definitely possible. Either one of these is possible. We just don't know. They both cross, positive and negative. So we really can't be conclusive either way. Either thing could be occurring. If this said which is more likely, well, you'd probably say one is more likely than the other because that number is a lot more positive than that is negative. But that's not, we're not asked to measure that degree. Hopefully that makes sense in just terms of a review of confidence intervals crossing over 0. And again, it's because that margin of error is actually bigger than the sample difference, even though I didn't give you the 2 sample proportions. All right, this one you got to jump from scratch. Bunch of data here to read about capital punishment. Hopefully you know what capital punishment is. This is the death penalty we're talking about. Some states do not believe in the death penalty. Some states do allow the death penalty. I think Vermont does not. States like Texas, I think, do. I'm not quite sure about that, but I think there are a few that certainly do. So there's 2 sets of data here being compared. This is, 1972 compared to 2006, and the question we're looking at is, is there a difference in whether people believe in the death penalty being okay or not? Is there any difference between these 2 things? So you have to actually calculate your sample statistics in this case. They're not given to you. And this is, how many people favor. So 937 out of the total people surveyed in 1972, and way more people here in 2006 are in favor. But again, it's relative to this total number of people that were surveyed in 2006. I believe if you find those 2 p-hats, which is the first part of this, I believe 66%, check me on this, if 937 out of the total there is 66%. And I'll check that and compare it to the data in 2006. Now it looks like, the raw numbers are larger, but relatively speaking, it's only a 3% difference between these 2. And again, those are samples, so we got to throw some hats on there. So the sample difference here that we're comparing is 3%. And what we're really going to check is, how does that 3% compare to the standard error? There's a lot of samples here. Both of these have a very large sample size. Is it going to be big enough to conclude that people like, the sort of the general feelings about capital punishment have increased? People are more likely to think capital punishment's okay now than it was 40 years ago. Actually, almost 50 years ago. So here we go. Again, just for this one, it happened to also being a 1.96 because it's a 95% confidence interval. The SEs where you just got to crunch some numbers here. And like I said, this is raw data. So you've got to sit here and find this percentage. 66 times 34 divided by your sample size. The sample size isn't given. You'd have to add those 2 numbers together, which I believe is 1410. Same exact process for the other one, 0.69 times 0.31, divided by this total sample size of all the people surveyed in 2006, and I believe that's 2,815, so they happen to get a bigger survey in 2006. Add those tiny, tiny decimals together once you calculate them, and then take the square root. Now, here's my decimals just so you can kind of verify you're doing this right. And the reason I'm showing you this is you can check if you're doing your work right. If you just go from here to here and copy this down, there's no benefit. This is kind of a waste of your time. Try to do this calculation. One of the steps in this process is understanding this process is actually being able to do the actual math, with help of a calculator. I think you get some really small numbers. This one has 1, 2, 3, 4 zeros. Clearly, this is going to have a much smaller effect on the error, on the spread of the data, because the sample size is so large. There's twice as many samples here as there are over here, which means this sort of has half the effect as this one over here. And I think if you end up finishing that calculation off, it's around 1.5% of standard error. So 0.015 is around 1.5%. If I take that number, it's kind of nice when you take that number and plug it back in for your standard error. This is a step people often forget, is they'll take the standard error and add or subtract it to the sample statistic and forget about Z in there. Don't forget about Z. You've got to multiply that by your confidence level Z statistic. So if you multiply this 2 times that, almost is 3%, depending on how many sig figs you kept on your calculator. Which, depending on how you rounded this off, that might cross you barely into the negative. If I just use 2 decimal places here, I can say I'm 95% sure of something. I'm 95% sure it's probably not negative, but it could cross into 0. You add those together, you get 6%. It does get to 0. So if I read back in my interpretation questionnaire, part B, is it plausible that the opinion on capital punishment hasn't changed? If there's 0% within this interval, that means maybe there's no change. There's 0% change. That is definitely possible. If you told me that the change has gone the other way, I'd probably say no, because I don't have a negative shown on here. So the fact that it's just saying it could be no change, sure, 0's in the interval, that's definitely a possible conclusion to draw. The last example on these no sheets, I'm going to skip it for now. I think I've given you enough of these to kind of work with. You should read through this. I'll come back to it later on at some point. It is crazy. I bet you can guess which country did this. If you look up this data, I believe this was done in China. It's a crazy example of these biologists. Doesn't even sound right, but it's legit. So again, skip it for now. We'll come back to it on a different video.